Hello everyone. It's October 27th, and we are going to do the challenge for tomorrow, the 28th, right? So we're gonna have is search in rotate. Oh, this is an old question, very very old question. Search in rotated sorted array. If I remember correctly, this is going to be binary search. But binary search with a little bit twist because the array is rotated, right? That's the only trick it has. And I think I've solved this problem at least 2 times, maybe 3. If you look at this, oh my god. Ooh, first time, 2019. And then 2020, 2 times. Solve this 2 times. Okay. So, given an integer array sorted in non-descending order, so increasing, right? Not necessarily distinct elements. Before being passed to your function, nums is rotated at an unknown pivot so that the resulting array is rotated. Right? So if we rotate it becomes this. Given the array nums after the rotation and an integer target, return true if target is in nums or false if it is not in nums. You must decrease the overall operation steps as much as possible. So apparently an easy solution, which I'm going to do right now, because let's just for fun. I don't want to do the easy solution to turn this into a set, and then that's it. But we're not going to do that. We're going to do the actual solution, which requires binary search, if I remember correctly. It's just how. How is the binary search implemented? What we know is it's sorted on one side, sorted on the other side, right? So if we're given a value, we'll go to the middle, right? We go to the middle, and what we know, hold on, let me write it out. Help me think. Okay, so if we write it out, we have 2, 5, 6, and then 0, 0, 1, 2, right? So we have the split here. So if we given a value, then we got a front and end, right? So we have the front, a low and high, right? And low or high could be simple, so it'd be the same. That's fine. So, and we go to the middle value, right? We'll go to the middle value, and if we go to the middle value, what we can do is when we get to the middle value, we can check if the middle value is on the left side or on the right side, right? So in this one, 0, 1, 2, 3, 4, 5, 6. So 3, 0, 1, 2, 3. So that's the middle value. How do we check? So the middle value, we know it's the middle. And if you look to the left, look to the right, now we compare. We compare the middle value to the left or to the right, right? So if the middle value is larger than the left value, then it belongs to the left half. If it's smaller than the right value, then it must be on the right side, right? So by doing that, we know which side it is on. And then we have the target coming in. And then we do the comparison, right? So we have these scenarios, 4 scenarios. Scenario 1, the middle value belongs to the left-hand side. And then our value is smaller than the mid value. Oh, that's actually a little bit tough. So our value need to compare as well. So we have to do multiple comparison. Okay, let's do this again. So we have a mid value, right? We first compare the target to the left and the right. So if the target is larger than the left, then it must be on the left-hand side. If it's smaller than the left, right? If it's smaller than the left, ooh, if it's smaller than the left, what's going to happen if it's smaller than the left? Well, if it's smaller than the left, we're going to say it belongs to the right, but it could be that the left and right are the same, all right? If they're the same, if they're the same, that's fine, right? So if my target value is the same as left or right, we're already done, right? We're already done. So the target value, if it's not the same as left and right, then we can enter this. Then it's either larger than the left, then it's going to be on the left hand side. If it's smaller than the left, then it must be on the right hand side, right? Okay. Yeah. So yeah, that's the comparison. We can always check on the left and check on the right. And then if it's equal to any of these, then we're already done, right? And if it's in between these two, then it's a none. Okay, so this could be the first thing we do, is we're going to check if the value is equal to the front, equal to the right, and if it equals to the left or right, then we return true. If it's in between left and right, if it's in between left and right, then we return false. Then it just doesn't happen. Okay, once we're done, we enter the real thing. So every value will come out. Not every value will come out. So what we can do is we'll do the comparison. If it's larger than the left, that's going to be, we know it's on the left hand side. If it's smaller than the right, it's going to be on the right hand side. Okay, that's good. And then we binary search. How do we binary search? We want to find out where the pivot is. Okay, we can find out the pivot. Not necessarily find out the pivot, but we go to we find a middle, right? And the middle we compare to the left and right. If it's larger than the left, then it's belongs to the left hand side. Smaller than the right belongs to the right hand side. And if I know the target is going to belong, let's say, to the right hand side, and then the middle we find out is belongs to the left hand side, then we're going to shrink the whole thing to the right. So the low is going to go to mid. Otherwise, high is going to go to mid. Right? We shrink to until we find the left hand side, and then do we even need to do that? Like, why don't we just compare directly to the target, the mid value to the target? So let's say I know the mid value is on the left or the mid value is on the right. And then if we have the mid is larger than the it's larger than the target, right? If it's larger than the target, if it's larger than the target, we still need to know if it's on the left hand side or right hand side, right? Yeah, we still need to know. So like every time we get a mid out, we still need to know if it's on the right hand side. So when we know on the right hand side, and then if it's not on the right hand side, we just keep going, right? We keep going until we hit the right hand side, and then we compare. If it's on the right hand side, we'll compare to the target value. We'll compare to the target, and if it's too small, so it's on the right hand side. If it's too small, right? So if I'm here, if it's too small, then left gonna move to mid, right? And then if it's on the right, this is the wrong hand side, so it's come in. Alfonso on the other side, too small. Then the left, yeah, I think it should work. I feel like it's gonna involve a little bit more. It's a little bit more involved. All right, let's try this. Okay, so if target is equal to nums 0 or target is equal to nums minus 1, then we return true. If nums minus 1 is smaller than target, smaller than nums 0, like in between these two, then we return false. So these are, to me, are the edge cases. And then we can say low, high equal to nums 0. No, 0, line nums minus 1. While low smaller equal to, smaller equal to. Let's go smaller equal to. Okay, mid, low plus high, divided by 2. Okay, so what we're gonna do is, if this value, right, so we know which side it belongs to, and if it's smaller than a target, yeah, any value that is smaller than a target, which means target is bigger. So if I'm here, target is here, right? The target is bigger. So we always need to move the left. In this case, limit is here, target is here, so always move the left. Okay, we move the left. If it's smaller, we move the right. Okay, we're coming here, so it's smaller, right? It's smaller, but it's on the wrong side. So we do need to know its side. Okay, let's find out the side. How do we find out its side? I don't know. So L and R, we can say side equal to, let's say 0 means L. So if target is larger than num 0, that means it's on the left side. Else it's smaller than this. Smaller than 0 must be smaller than num 1, so it also be 1. Let's just do left and right. So be on the left hand side, so be on the right hand side, right? So we have the side, and then we say if nums, so mid side will equal to left if nums mid is larger than, was actually larger equal to, right? Nums 0, else mid right. So if it's larger than 0 or smaller, and then it's going to be on the right hand side. And we say if side is equal to mid side, so it's the same, and mid side is the same. Then we compare, right? Then we say if nums mid is smaller, if it's smaller than target, right, then if mid is smaller than target, so we need to move the low. Say low will equal to mid plus 1. Else, if it's too big, then high will equal to mid. Else, if the side and mid side is not the same, okay? So if I'm here, mid is here, right? Then we need to move right. So if mid is at the wrong position, so we can be this and this position, and the mid is on the left, right? If mid is on the left, then what we need to do is move, move the left, right? Which is move the left. So say else if so side is not the same, right? Side is not the same. So we say if side is equal to L, right? So the actual side is L, and the new side is actually on the right. So we need to say high is equal to mid, right? Else, if side is on the right hand side, then low, let's say shall equal to mid plus 1. And keep doing this until we jump out, right? Then we return nums low is equal to target. I'm not sure. Oh my god. This shall be true, and this shall be false. Such pass. I am a little bit afraid. Oh, I should have put more test cases out there. Okay. How about uh-oh, we have an issue. I knew it. We're gonna have a problem. So 1 1 1 0 1 1. 0 shall be true, but I return false. Okay, let's see what happened. Oh, low and high, and side target 0 is larger than this. Nope, so it resides on the right. That is correct. Now mid comes up. Mid 0 1 2 3 4 5. So 2 0 1 2. So this is the first mid. So mid come out, so we try to find mid side. We say mid is larger than this. So mid becomes the left, which is true. And at side not equal to. So if side is right, so low equals mid plus 1. So low is here. Okay, low is here. So coming back, mid is going to be this one. All right, mid is this one. And then mid the side. Oh, it's on the shoot. Shoot. I should compare to the not 0. I shall compare to the low, right? If it's larger than, nah, that doesn't make any sense. If it's don't know where it belongs to. That's the problem. Yeah, if I larger than this and smaller than this, it can be anywhere. So hold on. If I have a mid, right, and then the left is something smaller, and the right is something bigger, right? So it could be this, could be this. But what I know is if this one is larger than something and it's smaller, so a more definitive way to figure out where it is if we give it a certain position and we compare the mid to the left, I will compare mid to the right, right? If mid is larger than the left and then larger than the right, that is indication it should be on the left hand side. Okay? If the mid is smaller than the left and is smaller than the right, that's on the right hand side. Okay? So if mid is larger than the left and larger than the right, oh, we've done this already. That's gonna be on the left hand side. So either it's the biggest one or the smallest one. Is there another possibility out there? I do not think so. Equal is another possibility. Let's say, oh, the three things are equal. The left, middle, right. What if the three things are equal? Then you cannot determine whether it's on the left or on the right side. If they're equal. Maybe the better way would be check my surroundings. We get a middle, is all we want to do is to identify if it's on the left and right side, right? So if I get my value, what if they're all the same? You cannot tell if it's on the left and on the right side. I mean, one way is just to ignore all the duplicates. Duplicates get things more complicated. I mean, But 5,000, why not? I mean, we can just remove the duplicates. Whenever we see the duplicates, we just skip it. So eventually we end up with an array with no duplicates. Well, might as well, if we do that, might as well just check directly, right? So no. How do we handle the duplicates? Yeah, it could be situation. The duplicates, I cannot tell if it's on the left or on the right hand side. Or you could try to find the smallest value. If you find the smallest value, then using that we can determine that alone. We can determine. Right? Let's say we have the smallest value. Then the mid is compared to the smallest value. And if it's equal, it could be the right hand side or the left hand side. Doesn't matter. And the smallest value to the left is the biggest value. Now we have the entire thing mapped out. I am not sure, honestly. Are we ON? The question, if it's ON, why don't we just go directly ON? The whole purpose is to make it O log n. That's the whole purpose. That's what we're trying to achieve. But we cannot determine if it's on the left or on the right side. Yeah, I feel like I need the minimum value. Okay. All right, so the mid side, then we have a good understanding, right? So we just say the minimum value, right? And we can actually get a maximum value. I mean, seriously, if we do it this way, what's the point? Like, what's the point? We can just, if we want to do this, we simply return this target in nums, and that's it, right? If we want to do it, and then I'm pretty sure this one will pass, but it's not. This is not what we want, right? This is not what we want, and that's pretty fast. That's not what we want. What we want is using. But if you do the minimum, what's the purpose of doing the minimum? We try to do it on log n instead of on. But currently, what I find out is I can't, because the duplicate really complicates things. I don't know if it's on the left or on the right side. I mean, I can make it work, but what's the purpose? What's the point? Like, if I do this, let's say, right? If I do this, we can simply say if, let's say nums 0 smaller equal to nums this and smaller equal to, I don't know, max n, then it should be, oh, it's still not right. Yeah, it's still not right. Hold on. So we got a middle, right? And then we do target compared to the middle. The middle could be on the left, could be on the right. Let's say we don't know. We don't know for sure where it belongs to. And then we find out the target. If the target is equal to the mid, then we're done, right? If target is larger than the mid, if mid is on the right hand side and the target is larger, then we do move the left. If target is on the left hand side and it's larger, oh, we also move the left. Hold on, are you saying it's actually the same? If it's smaller than the target is smaller than this. If on the left hand side is smaller, then we move the right. If on the right hand side is smaller, we also move the right. So what you are saying is we don't even need this. We are the mid, right? And we can simply say if nums mid is smaller than target. Okay? If nums mid is smaller, so target is bigger. Okay? If target is bigger, no matter if you're on the left hand side or on the right hand side, you do the same thing. Low or equal to mid plus 1. Else, nope, that's still not right. Because 0, 1, 2, this one's coming out. then 0 is smaller than this. All right, 0 is smaller than this. Say when it's mid a certain value, and then if smaller, then we move right. Yeah, we move right, and that's not right because this 1 belongs to the left hand side. It's not belong to the right hand side. Yeah. Its mid is smaller than the target. There are two scenarios. Smaller than the target. If the target is larger than the if the target is smaller than, so either it's within left or it's within right. Both are good, but just the problem is if it's split. Right, the mid is on the left and the target is on the right. And in that case, this is a smaller, right? Now we should move the low. Then how do I know? Well, the mid I compare to the front. I compare to the back. But they can all be same. So I got stuck. The thing is, if I know the minimum, then I can know. But if I find a minimum that's ON, then we might as well just do this. I don't know. What's the solution? Binary search. O log n. O in worst case, log n best case. How'd you search? So actually the problem, okay. So what I think the problem is just if these are the same. Oh, I just had an idea. If we keep walking until the position where they're not the same. So I checked this already. So those things, the front and back is useless. So I can just keep walking until they're not the same anymore. Right? Then we have a new low, have a new high. Once we grab that, and then it's guaranteed. Right? It's not gonna be the same. Hold on, let me see. Because in that case, when we have a mid, it's not going to be the same as the left. It's not going to be the same as the right. Okay, so we get a mid. If it's larger than the left, that must be on the left-hand side. Right, so if the target is smaller, right, if the target is smaller, and that, and then we can use this to compare. Okay, so here's the thing. You can say while nums low is equal to nums high. Low plus equal 1, high minus equal 1, until they're not the same. Then we do this. Then we have the mid, right? And then we can say if nums mid is smaller than target, okay? So target is bigger. So nums mid, well, that's what depends on. Then we can see where this thing is. If they're on the same side, or if they're not on the same side. Okay, so we should first check if they're on the same side. If they're not on the same side, like let's say mid is on the left hand side, target is on the right hand side. So this is going to be target going to be smaller than mid, right? And it's smaller than left. Now, in this case, maybe it's just really easier to. So we just say target side, right, equals left, right? If I say target is larger than nums, I don't know, nums high, right? If it's larger than, it can go on the left hand side. Else, right, okay? And now I have mid, so same thing. So mid side will equal to left if nums mid is larger than nums high. Else, right? So we get the position, and then we say if target side is equal to mid side, right? If they're the same, then we do the traditional thing. If they're not the same, okay, if target side is not the same, then we say if target side is on the left, right, if I say target side, not target side, mid side is on the left, then we can move to the right, then we say low equals mid plus 1, else high equals mid. Okay? So this is the key. Say remove duplicates that cross at both ends of nums. That's the key. I'm gonna try this one. We're gonna try it directly. Ew. Ooh. Good test case. Shall be false. Low smaller than high. Okay. Huh. Maybe I combine these two. No, I should not. different while low is smaller than high. And try this. Ha! Five. Yep, come back to the trial and error. The heck shall be true. Huh. How? We didn't go through this. We don't have to. And the target is 5. 5 is larger than this, so it should be on the right, should be on the left hand side. Okay? So low and high, okay. Mid is 5. And mid is equal to the left. Uh-oh. It should be larger than high. Oh. That's actually correct. It's larger than high. 5 is larger than 1. So it's on the left. So it's the same. The num's mid is 5. Is smaller. No, it's not smaller. So it's equal to. So we say high equals mid. So high will come here. So low and high. Right? So coming back. Mid. 0, 1, mid go to 3. And 3 is off on the left hand side. And then nums mid is 3 is smaller than 5. Yes. So low equals mid plus 1. So low equal to 5. And go back, and the low and high both points to 5. Coming out. How is this not true? Yeah, 0, 1. It's low. 0. How come it's 0? That doesn't make any sense. Hold on. We had 3 and 5. And num's mid is 3. 3 is smaller than 5. Shouldn't low become high, which is 1? Mid is 1. Huh? I think the mid side is wrong. Yep, mid side is wrong. I see. I see. These are different. I see. I see what this is. Should be L and R. Okay. L, R. L, R. L, R. And then we have, this should be R. Low, high, R. Yep. I am pretty sure that is the issue. So basically kind of reset the, I just said I think it's the issue. We have a new error. That is not good. Alright, so what happened? So here, right? It's equal, equal, then not equal. So we have 1, 0. Okay? 1, 0 is left and right. Hey, that's not true. Left and right. There we go. Now we're talking. Now we're talking. Okay, so this one might be it. Yep, that is it. Why it took so long? Alright, the key is to remove the duplicates at both ends of the nums. Right. By doing this, we can easily determine whether a given number is on the left or right half of the given array of the rotation. Right. And then use binary search. Right. If nums mid and target are on the same side, simply perform binary search within that side. Otherwise, we move low or high to approach current side of the target. Or log in. On average, worst case, on, right, where all values in nums are the same. Yep, that's my solution. I don't want to read errors, but I do want to see what I did back in the old times. Okay, this is not what I was looking for. Oh, that's today's solution. We only need to move one side. Oh. But it's the same. For me, it's easier to consider it this way. Yeah, this feels like the same logic. Okay, so we did it, and yeah, I don't want to do another one. I'll probably handle the other one tomorrow. All right, adios. See you guys tomorrow.